Are you curious about this complex world of explainable AI, but confused by the buzzwords and acronyms? You are not alone. So, today we will simplify and demystify explainable AI by exploring some of the most popular and effective techniques, including guided backpropagation, grid camp, targeted class activator functions, influence functions, representer points, and tracking influences. So with practical examples, you will gain a solid understanding of how explainable AI works and how it can help you build more trustworthy and transparent machine learning models. So let's start with what is explainable AI. So basically this explainable AI is a branch of artificial intelligence that aims to make the decision making process of AI models more transparent and understandable to humans. So in simple terms, it is about making AI more explainable so that we can understand why a certain decision was made, how it was made, and how we can trust it. A simple real life example of explainable AI is a self-driving car. So imagine you are riding in a self-driving car and the car suddenly brakes when there is no obvious obstacle on the road. So with explainable AI, the car's AI system can provide an explanation for why it brakes, such as detecting a pedestrian crossing the road or identifying a traffic light turning red. So this transparency helps us understand why the car made the decision to brake, increasing our trust in the AI system and making it more user friendly. So in essence, this explainable AI is about making AI more transparent and understandable so that we can have more confidence in the decisions it makes and better understand how it works. Then comes guided backpropagation. So this guided backpropagation is a technique used in explainable AI to understand how different parts of an AI model contribute to its prediction. And it works by guiding the backpropagation process, which is a key part of training a neural network. In simple terms, this guided backpropagation allows us to see how the model looks at and interprets the input data to make its prediction. So here the simple real life example of guided backpropagation can be a medical diagnosis system for detecting a disease from medical images, say MRI or CT scan. So when this patient medical image is fed into the model, guided backpropagation can help us understand which part of the image the model is looking at when making a diagnosis. And by visualizing the area of image that are most important for the diagnosis, we can gain insight into how the model is thinking and identify any potential bias or errors in its prediction. So to summarize this, we can say this guided backpropagation is a technique used in explainable AI to understand how an AI model is making its prediction by visualizing the most important parts of this input data. And this can be useful in many applications such as medical diagnosis to gain insights into the decision making process and improve the overall performance of the model. Then comes GradCamp or the gradient weighted class activation mapping. Now this GradCamp is an explainable AI technique that provides visual explanation for the predictions made by deep learning model, and it works by highlighting the most important part of the input image that contributes to the model prediction. So in simple terms, this GradCamp is like a spotlight that highlights the key areas in an image that the model focuses on when making a prediction. Here, a simple real-life example of GradCamp is an image recognition system for detecting objects in photographs. So when a photograph is fed into the model, GradCamp can highlight the specific parts of the image that model is looking at to determine what object is present. For example, if the model is trying to identify a car in a photograph, so the GradCamp might highlight the wheels, headlights, and roof of the car as the most important parts of the image. So in essence, this GradCamp is a explainable AI technique that helps us understand the reasoning behind predictions made by a deep learning model by visualizing the most important parts of the input image. And this can help us to improve the transparency and trustworthiness of the model and can be useful in many applications such as medical diagnosis and autonomous driving. Then comes targeted class activator or the activation vectors. Now this targeted class activation vectors is an explainable AI technique that helps to understand how different parts of an input contribute to the prediction of specific class. And it works by creating a vector of weights that represent the importance of each part of the input for a specific class prediction. So in simple terms, this targeted class activator or the activation function is like a set of instructions on how to modify the input to make it more likely to belong to a specific class. So here the simple real life example of this TCAV can be a facial recognition system that is used for access control. So when an image of this person face is fed into the model, this TCAV can generate a vector of weights that describe the most important facial features for identifying that person. And by modifying the image based on these weights, the model can be nudged to make a more accurate prediction for that specific person. So to summarize this, we can say this TCAV, or testing with concept activation vectors, is an explainable AI technique that helps to understand how different parts of an input contribute to the prediction of a specific class. And it is useful for improving the transparency and trustworthiness of AI models, and can be applied in various applications such as facial recognition to make more accurate predictions and enhance user experience. Then comes influence functions. Now, these influence functions are an explainable AI technique used to understand the impact of individual input features on the predictions made by the machine learning model. So here the influence functions measure the change in the model's prediction when a specific feature is modified while keeping all other features constant. So in simple terms, this influence function tells us how each input feature influences the model prediction. So let's take a simple real life example of influence functions where it can be found in a recommendation system for online shopping. So when a user's profile is fed into the model, influence functions can help identify the most influential features. Example, age, gender, past purchase, that contribute the most to the recommended products. So by understanding these influential features, the users can make more informed decision, and the system can be fine-tuned to provide more personalized recommendations. So in essence, these influence functions are a powerful explainable AI technique that helps us to understand the impact of individual input features on the predictions made by a machine learning model. And this can be useful in many applications such as recommendation system to improve transparency, trustworthiness, and personalization. Then comes representer points. Now, this representer points are an explainable AI technique that provides visual explanation of a machine learning model's decision making process by identifying the input data points that are most representative of this model's prediction. And these points are selected based on their high similarity to the original input data, while still providing a clear visualization of the model decision making process. So in simple terms, representer points are the most important examples that represent the model's prediction and help us understand how it makes its decision. So here simple real life example of representer points can be found in credit scoring model. So when a credit application is submitted, the model evaluates various factors such as income, credit history, and debt to income ratio to determine the likelihood of default. So using this representer points, we can identify the specific input data points that are most representative of the model's prediction, such as highest and lowest credit score or the most important debt to income ratios. So by visualizing these representative points, we can gain insights into how the model is making its decision and identify potential areas for improvement. So to summarize this, we can say representer points are an explainable AI technique that helps us to understand the decision making process of a machine learning model by identifying the most representative input data points that contribute to its prediction. And this can be useful in many applications such as credit scoring to improve transparency and trustworthiness and to inform model improvements. Then comes tracking influences. Now, this tracking influence is an explainable AI technique that tracks the changes in the output of machine learning model when the input features are modified. And it provides a detailed understanding of the relation between the input features and the model's prediction. In simple terms, this tracking influences helps us to understand how different input features affect the model's prediction when they are changed. So here the simple real life example of tracking influences can be found in a facial recognition system that uses a machine learning model to identify individuals based on their facial features. So whenever a new image is submitted, this tracking influences can track the changes in the model's output as the features such as the position of the eyes, nose, and mouth are modified. So by analyzing these changes, we can gain insights into how specific facial feature contribute to the model's prediction, which can help to improve the accuracy and reliability of the system. So in essence, this tracking influences is an explainable AI technique that tracks the changes in the output of machine learning model when the input features are modified, providing a detailed understanding of the relation between the input features and the model predictions. And this can be useful in the task such as facial recognition to improve transparency, trustworthiness, and performance. Thank you.